Hey everyone, I'm Michael Unger, Program Coordinator here at the HR MacMillan Space Centre. Welcome to another of our live chats that we're going to do with our astronomer, Rachel Wang. Hey Rachel, how's it going?
Hello, excited to be here to talk about exoplanets.
Yes, exoplanets. So we started this week off on Monday night. We did a special event. May the 4th was the date, which means it was May the 4th be with you. It was Star Wars Day. And we started the conversation all about the search for alien worlds that day, Rachel. Is that right?
It is, yeah, looking for Wookiees and Ewoks in our own galaxy.
And we certainly found them. Put in the chat right now if you were at that event on Monday, and that chat feature that you see on YouTube is what you're going to use, because Rachel's going to do a little short presentation about exoplanets, and then we're going to use the rest of the time just to delve into any and all of your questions. And we've got a whole bunch of cool links. And then afterwards, you can go back and check out the Star Wars Day stuff, an interview I did with the ILM members as the Industrial Light and Magic. Those are the team that make all of the cool special effects on Star Wars. And inside of that event, Rachel did get into all about exoplanets, and that is what we're going to delve into even deeper right now. So Rachel, why don't you start us off? Like, what is an exoplanet, just to begin with?
Sure, it's just a planet that exists outside of our solar system. So in our solar system, we have eight plus one, which I'm going to say is Pluto. Unfortunately, got demoted. But yeah, just planets that we find outside of our solar system.
Okay. So like Tatooine or some of those Hoth,
Or Hoth,
those are
yeah,
exoplanets. Okay.
exactly.
All right. Well, yeah. So, Rachel, why don't you take it away and give us a little bit of a short presentation, and that'll prime anyone out there watching. Use the chat feature to ask some questions.
Sure, I'd love to. So today we're talking about other worlds far from our own. So far, in fact, that they exist outside of our own solar system. We're of course talking about exoplanets. And why are we talking about exoplanets? Because everyone at some point in their lives has probably asked the question, are we alone out here in the universe? Or you might have asked yourself, are there aliens? And what's in Area 51? And because I could talk about exoplanets for hours, because there's literally thousands of them, I've broken down our exoplanet discussion into four main categories. So first, a brief introduction to exoplanets and their history. Then we'll move on to habitable zones to talk about where the best places are in the universe for potentially life-bearing planets. After that, we'll talk about the ingredients and signs for life. And finally, we'll end with the planet hunters of the past, present, and future, and how they go about searching for these distant worlds. Now I'm going to switch over to Uniview. The software is, of course, the same software that we use in our planetarium. So you'll notice that it is a big circle instead of that regular rectangle that you're used to. Now, like I said, an exoplanet, or what we call also an extrasolar planet, is a planet that exists outside of our solar system. It's usually orbiting another star, and I say usually because you can have rogue planets that are free floating, which orbit a galactic center directly, but were once formed around stars. And at some point, they got ejected into interstellar space where they roam until their next gravitational interaction. Now, where are all the exoplanets? Well, they do show up in a lot of different places. The first exoplanet discovered back in 1995 was orbiting a sun-like star, and it's called 51 Pegasi b, and it looks a little bit like this. Now, to date, we found and confirmed the existence of 4,152 planets. And you can see some of the locations of those planets right here with these blue markers. Now, most of the exoplanets discovered so far are in a relatively small region of the Milky Way galaxy. But of course, by small, I really mean small in terms of astronomical scales. So it's still within thousands of light years of our solar system. Now, if you take a look at this image, it shows our solar system in relation to the Milky Way galaxy. And this white circle here indicates the area where the majority of exoplanets have been found with current telescopes. So this is as far as current telescopes have been able to probe for exoplanets. So now that we know what an exoplanet is, where can we find them? And not only that, where should we look if we want to find potentially life-bearing worlds? Well, scientists look in a region called the habitable zone, or something called the Goldilocks zone. Now, much like the fairy tale, it's an area around a star where it's not too hot, not too cold, but rather just right for liquid water to exist. on a planet. Now, here we are at the TRAPPIST-1 system, and here is the habitable zone, or the Goldilocks zone of this system. Now, I want you to imagine what would happen if Earth was where Pluto is. The sun would be barely visible. It would be about the size of a pea from the perspective of Pluto, and Earth's ocean and much of its atmosphere would freeze because it's so cold, it's so far away from the sun's heat. Now, on the other hand, if Earth was at Mercury's location, then it would be way too close to the sun, and a lot of its water would form as steam in the atmosphere, and it would boil off. Now, the distance Earth orbits the sun is just right for water to remain a liquid on the surface of our planet. Now, rocky exoplanets that look like Earth and are found in the habitable zones of their stars are more likely targets for science instruments for detecting liquid water on their surfaces. But that brings me to the question, well, why is finding liquid water so important? Well, life on Earth started in water, and water is a necessary ingredient for life as we know it. It dissolves nutrients for organisms to eat, transports important chemicals within living cells, and allows those cells to get rid of waste. Now, for humans to survive, we also need oxygen and an atmosphere, or a spacesuit if you're an astronaut, so that we can breathe. Now, from space, you can see the protective bubble that is the atmosphere, this almost invisible barrier that protects humans on Earth from the 270 degrees Celsius or negative 270 degrees Celsius of space. And if we compared Earth to an apple, our atmosphere would be thinner than the skin of an apple. Now, by studying the chemical composition of exoplanet atmospheres, researchers can learn a lot about the physical and potentially life-bearing conditions on these distant worlds. And we also know that we need food or an energy source to survive. So our planet needs to have a solid surface that we can farm crops on and jumpstart agriculture. Well, we could also terraform other planets like Mars to try to modify its atmosphere, temperature, and surface features to be similar to environment here on Earth. And we're looking for signs of life because when we're searching for exoplanets, we want to begin on familiar ground. We want to find other worlds that could potentially host and sustain life just like Earth does. So let's talk about the planet hunters of the past, present, and future. So we'll start with the past. We have Kepler. Now, after 9 years in deep space collecting data that revealed our night sky to be filled with billions of hidden planets, that's more planets even than stars, NASA's Kepler Space Telescope ran out of fuel needed for further science experiments. So in 2018, NASA retired the spacecraft within its current safe orbit away from Earth. Now, Kepler leaves a legacy of more than 2,600 exoplanet discoveries from outside of our solar system, many of which could be promising locations for life. Now, technical difficulties on board the Kepler spacecraft in 2013 brought an end to its 4+ year science mission. And now we have K2 that became fully operational in 2014 and ended space operations in 2018. And together, Kepler's legacy left over 150,000 stars to search for transiting exoplanets. And then shortly after came Planet Hunter TESS. So TESS is currently having an ongoing mission right now, and it was launched in 2018. Now, TESS stands for the Transiting Exoplanet Survey Satellite, and it's a space telescope designed to search for exoplanets using the transit method. Now, during its 2-year primary mission, it was expected to find more than 20,000 transiting exoplanets, compared to the about 3,800 exoplanets known when it was launched. And then we have upcoming in hopefully March of 2021, we have the James Webb Space Telescope. Now, one of the main uses of the James Webb Space Telescope, or JWST, will be to study the atmospheres of exoplanets to search for the building blocks of life elsewhere in the universe. But you might ask, well, I've heard the JWST is an infrared telescope. Now, how will that help us study exoplanets? And that's a great question. Well, Webb will use a technique called spectroscopy to help study and characterize exoplanet atmospheres. And it'll also carry coronagraphs, which is a type of telescope that can see very close to the sun by using a disk to block the sun's bright surface. It essentially produces an artificial solar eclipse. And these coronagraphs will allow Webb to directly image exoplanets near bright stars. So spectroscopy is the science of measuring the intensity of light at different wavelengths. Now, when we put these measurements into a graph form, like here on the right, they're called spectra, and they're key to unlocking the chemical composition of exoplanet atmospheres. Knowing the chemical composition of these atmospheres can tell us a lot about the physical and potentially life-bearing conditions on these worlds. Now, how does it work? Well, when an exoplanet passes or transits in front of its host star from our point of view here on Earth, a small fraction of the star's light passes through an exoplanet's atmosphere, where molecules absorb light of some wavelengths, while other wavelengths can pass through unhindered and uninterrupted. And by measuring the fraction of light able to pass through the atmosphere at different wavelengths, we can infer what elements are present. Now, take a look at the GIF on the left. We see a planet moving or transiting in front of a star, which decreases the overall brightness that we see here on Earth. Now, from this data, we can infer that the planet has an atmosphere that absorbs blue and green light really efficiently, but allows red light to pass right through. So why is an infrared telescope like James Webb key to characterizing the atmospheres of these exoplanets? It's because at infrared wavelengths, molecules in the atmosphere of these distant worlds have the largest number of spectral features, which means it gives us the most amount of information to study these atmospheres in infrared rather than any other form of light. And lastly, I wanted to share with you my favorite exoplanet. It has a very catchy name. It's called HD 189733b, and it lives approximately 65 light years away from the solar system in the constellation of Vulpecula. It's a faint constellation in the northern sky that is named after the Latin word for little fox, which coincidentally is my favorite animal. The planet was discovered in 2005 by French astronomers, and it's known as a hot Jupiter, which is a special class of gas giant exoplanets that are physically similar in size to Jupiter, but orbit really close to their host star, giving them really high surface and atmospheric temperatures. Now, the daytime surface temperature on this planet actually hits almost 1,000 degrees Celsius. Now, this extrasolar planet is actually the closest transiting hot Jupiter to Earth, which makes it particularly interesting and useful for astronomers to study its atmosphere. But the best part about this planet, in my opinion, is its absolutely deadly weather. Its winds reach up to speeds of 2 kilometers per second, which is 7 times the speed of sound. And on top of that, its clouds are laced with silicate particles. So because of its high temperature orbiting so close to its host star, the exoplanet's atmosphere gets blowtorched, and silicate particles turn into molten glass. And those fast winds that are 7 times the speed of sound pick up that molten glass, making it rain sideways on this killer world. And that brings me to the end of my talk. So Michael, I'll throw it back to you and let's get started on this Q&A.
Yeah, absolutely. And I love these sessions that we have, Rachel, because I actually get to learn about you. And I learned that your favorite animal is the fox. I'd never heard that before.
Yeah.
Why is the fox your favorite animal?
Oh, I think it's because, of foxes, Arctic foxes are my favorite because they are white in the winter and black in the summer. And I feel like I really go through those phases through the seasons as well.
Yeah. Okay. So you have a connection. Cool.
Yes.
If you have questions, we're going to delve into exoplanets, and then we can open it up to really any questions you have. So put your questions in the YouTube chat. But we'll sort of let's kind of go back a bit and kind of like start where we started last on Monday, and talking about the big variety of different alien worlds that are out there. And when we were talking about Star Wars worlds, we were talking about gas giants. We were talking about icy worlds. Now, which of these worlds do you think would have like the best chance for finding life as we know it, so to speak?
I get this question a lot. I get the question, are there aliens and where do we find them? And my answer is always, if we were to find life somewhere, of the places that we've looked, I really think Enceladus is a great place to look, because Enceladus has this really thick ice sheet that floats above an underwater ocean. And what's cool about Enceladus is you wouldn't expect it to have water because it is outside of the habitable zone. So it's kind of in the range of all the icy gas giants where Pluto is, where it's really, really cold. And the reason why it has liquid water underneath is because of tidal friction. So like that same idea of rubbing your hands together is kind of the same thing that's going on between Saturn and Enceladus, and their gravitational interaction is causing that kind of friction between the ice sheets, which melts some of the ice. And I really think that life could exist underwater on Enceladus, just like life exists in hydrothermal vents here on Earth.
Yeah, that's really interesting because we had talked on Monday about the intersection of art and science. And, Star Wars presents this idea. A lot of the worlds that you see are moons of planets. And it seems that those are better places to inhabit life. So far we've only got one place, in the universe that has life, but we are looking at a lot of these moons as possibilities, but those are harder to find, obviously, when you're talking about these exoplanet techniques, right?
Yeah, because you're thinking that, well, moons are smaller than the planets that they orbit. And we're already having a little bit of trouble finding a lot of planets because we use something called the transit method to survey a really large portion of the sky. And the transit method is that idea of a planet passing in front of or transiting across its host star, and it blocks some of that light. And you're looking really for that fraction of intensity or brightness that's it's changing by, right? So it's harder if you have something that's much, much smaller, blocking less light. And so you have to have more sensitive instruments to look for things like that.
Interesting. Do you think that there would be a possibility of liquid water being on a moon of a planet?
I hope so, because then my Star Wars dream will come true.
Yeah, because so far when we're thinking about a lot of the moons in our solar system, we're talking about frozen worlds, right? So, at the moment, it's going to be tricky for us to find that life. But we're always kind of like looking for that, almost that home run to be kind of like, oh yeah, that's the world. And when we're talking about that, we're talking about liquid water, right? If we can find a place that has liquid water, we're going to have a good chance of finding that life as we know it.
Exactly. And it's hard when these planets are, they exoplanets existing outside of our solar system. And we are very used to sending probes to go and physically look and sample chemical signatures from these planets. So we're having to shift our mindset back into, okay, well, we can't physically go to these planets because it would take way too long. And so we have to do things from afar.
Yeah, which leads to a great question from our audience, because we have been talking about carbon-based, water-based life. Jasmine E90 asks, do you think life can exist without water?
I'm not going to rule it out. And the reason I say that is because we do have a moon, Titan. That's Saturn's biggest moon. It's very aptly named. And it has liquid methane lakes. So there's no reason why, if there was a methane-based life form, that it couldn't survive on a planet like that. But we are starting on familiar ground. So we're searching for planets that look a lot like Earth because we know that life exists for sure here on Earth. So we're starting from that familiar standpoint.
Yeah, awesome. Let's see what else we have here. Should we get into some other topics? We are going to be delving into next week. We're going to be delving into our place in the universe, which we're really talking about scale. So if we sort of like tease out next week's theme a bit, our place in the universe, let's talk about exoplanet scale. Now, how far away are some of like the closest exoplanets from us?
So I believe the closest one would be Proxima Centauri b, but that one I believe is around 4.4 light years away. And even then, it's going to take forever for us to put a person on a spaceship and travel there. So when we're talking about distances in our universe and being able to travel to exoplanets that are very far away, we might have to come up with some sort of faster than light form of traveling first before we're able to physically visit planets like that.
Right. And even if we do find a way to travel there, traveling for humans to travel there seems almost near impossible at this point, right?
Yeah, I think it's still living in the realm of science fiction, but I'm hoping it'll translate to science fact decently soon.
Well, maybe there's some way that we can, download like our consciousnesses into like a computer, because it's really our bodies that are hindering us from going out to space, right? But as we see computers and robots, they can withstand those distances as well. Then the next trick would be to actually get a spacecraft to travel that quickly.
Exactly.
Some more questions from YouTube. What about the extremophiles here on Earth? That's a great question.
Ooh.
So the aliens that we find here on this planet.
I think that extremophiles are a great place to start because space is an extreme environment. A lot of the places and locations that we're visiting and looking at aren't super similar to Earth, and they do have harsh conditions, like my favorite exoplanet, which rains molten glass. So being able to find extremophiles, these organisms that can withstand these extreme environments, would be useful to see, well, let's see where they can live, how do they live, and where should we look for them.
Right. And some of these extremophiles, we've done experiments with them. We've sent them up to the International Space Station, and they seem to be incredibly durable. Like, these are tiny microscopic organisms that have been on this planet long before any of us have been here. So it is very, very easy to make that leap to think that extremophiles may be more common in the universe than, say, intelligent life.
Exactly.
Another question coming in from YouTube: do we assume that DNA is synonymous with life?
Ooh, this is a tricky question.
Yeah.
Mostly because I stopped taking bio after high school. But I will say that something that's really interesting, that is somewhat tangentially related, is RNA, so ribonucleic acid, rather than DNA, which is deoxyribonucleic acid. And what's cool about RNA is that last year they found ribose, which is a sugar in RNA, on an asteroid. And that really lends itself to a hypothesis that we have that perhaps maybe life started on Earth from asteroidal impacts that had all these sugars on it. And somehow, through a very serendipitous chain of events, life began from these sugars. So I think that that's a good place to start, much like studying the extremophiles, looking at asteroids and seeing what kind of sugars that they hold and how frequent these impacts are to deliver life.
Nice. So we've got about 9 minutes left. Rachel, why don't you take us through? We've put a whole bunch of extra resources into the YouTube description, so that after we're done here, you can delve in even further. And we've got some cool stuff on there, including some neat posters that NASA put out. I believe they have one of your favorite planet. Did you want to share that with us?
They do, sure. I would love to. So let me just share my screen really quick. And so hopefully you should be able to see the NASA exoplanet webpage. And it's got a bunch of coloring sheets on it. And I'll scroll all the way down to, this is my favorite one. And it's very aptly named. It's called the Rains of Terror because it does rain molten glass sideways. And I think that that's amazing. And I'm actually thinking now that I should probably print this off and put this in my room.
Yeah.
Yeah.
So you can go to this website that we've got the link in the YouTube description if you want to print out your own super cool poster. But look at those cool coloring sheets as well. Parents and kids, if you want to do some coloring of your favorite exoplanet, you can go to this website, print them off. But there's also a website where you can actually do some citizen science. Why don't you tell us a little bit about the test project here?
Sure. So this is from Zooniverse. Zooniverse has a whole bunch of different citizen science projects you can do. I am specifically in the space section, where you can actually help one of the planet hunters, Tess, and searching for these worlds. So I'll show you a little bit about how to do it. So here we'll start. You can go through the tutorial, but I'll show you. So all you have to do is search for a U shape. So a little something like this. So you have a bunch of data, and then all of a sudden your planet or exoplanet transits in front of its host star and blocks the light. So it'll dip like a U. And what we're really looking at is called a light curve. And you can see on the y-axis, we have brightness, so the intensity of light that we're seeing here on Earth. And on the x-axis, we have time in days. So we're really looking for these U-shaped dips. And all you have to do is, when you find one, highlight that U shape, and you've discovered a transit. And this really helps scientists filter through the data sets, and it helps train their machine learning program as well.
Awesome. And this is really cool because this is, and the reason that they do this, because there's so much data that they need help from people at home to go through some of this data. And there's a really good possibility that people at home could discover their own exoplanets. Is that right, Rachel?
Yeah, that's exactly true. And also, if you contribute to this project, you will get your name added to any scientific papers that are published.
Okay, I know what I'm doing later tonight.
Yeah.
That is so cool. Yeah, citizen science is a really cool phenomenon that has come out recently. It's not just in searching for exoplanets, but also asteroids as well. Because this is a big project. We need to have more telescopes looking for some of these objects, and lots of citizen science has been coming out to help us find some of those objects. And you can think, wow, what an amazing contribution, not only to science but to humanity, to discover some of these things. And it all has to do, like, you think, like, there's just tons and tons of scientists, like all around the world doing this stuff, but there's too much data for us. So I think it's a great opportunity for anyone at home to try some of this stuff out.
And I really think it's a great testament to science being truly a collaborative endeavor, right? So you have things like the International Space Station, where they have flags from all the participating countries around the world. And I think it's really cool that even me sitting at home in my sweatpants, I can contribute to science.
Awesome. And on the topic of asteroids, we got a question from Harry Wang, talking about being blindsided and hit by a foreign object. So he's got two questions here, but we'll sort of talk about that one. Maybe talk about being blindsided by some of these foreign objects.
Sure. So I think that was in the news recently because we had a close flyby of an asteroid. And I get this question a lot of people being worried that we're going to be the next extinction event right after the dinosaurs with a big asteroid impact. And we do have systems in place. So NASA has a bunch of satellites that are checking around our planet for close flybys and making sure that we're prepared. And if in some way we do have a close encounter with an asteroid, we do have different methods of dealing with them. One of them we actually use to deal with space debris, and it's called laser ablation. So it's this idea that we fire a laser and we try to alter the course, alter the trajectory of the incoming object.
Right. So just like, how we prepare for any of these other disasters, like a pandemic, say, an asteroid, is certainly something that we need to be planning for right now. And besides that technique, like what would be some of the actions that NASA or other organizations might take if, say, like tomorrow we found one heading straight towards us?
Ooh, if tomorrow, because that's a good, interesting question, because we would know weeks to months in advance if one was coming. I imagine that they would probably try to send some sort of rocket, some sort of object on a collision course with it. So doing a controlled collision with the asteroid, just enough to change its momentum and force it in a different direction.
Yeah. Yeah, no, certainly, it sounds like whenever I think about those scenarios, it certainly sounds like we would love to give ourselves as much time as possible. Sort of to do that, we need to find these objects, which means we need to send up more telescopes. And I'm always surprised when I hear these missions that there isn't more of these missions. Like, this should be something that, like, the entire world should be focused on. But we're actually going to delve into that on June 30th. Asteroid Day is a anniversary of the last major impact that the Earth had, which was, there you go, the Tunguska event. It was in Siberia. There was a large object, but nobody was living there. It was, thank goodness, but it leveled this entire forest region. It was incredible. And they actually didn't realize that it happened until later because nobody lived in the middle of the forest in Siberia. But it was certainly, if there was a city there, there would have been a lot of loss of life. So we're going to delve into the science of asteroids on June the 30th. And for our final question, also from Harry Wang, he was talking about going back to the moon, which is something that I think we are all pretty excited about. So when's that happening? Who's going? What's happening here?
So it's planned for 2024. It's NASA's Artemis 3 mission, Artemis being the twin sister of Apollo in Greek mythology. And what's really cool about this mission, what I'm very excited for, is NASA has promised that the first female will walk on the lunar surface with these missions as well in 2024. And so the goal of this mission is to build an ISS-like space station around the moon called the Lunar Gateway. And it's supposed to be fully autonomous. We'll be building another Canadarm. It's Canadarm3 now. And also autonomous robots like Dexter to help out maintaining onboard operations while humans aren't there. And so they'll be able to pop down to the lunar surface whenever they like and conduct science.
Yeah, that's awesome. That's really cool how Canada has this direct connection to this next phase. So kids right now that are in school that are thinking about, wanting to go out into space, like this is a very real possibility. Maybe not physically going out into space, but like to think about working on that next Canada 3 arm project. Because like you say, Rachel, when we go back to the moon, this is going to be the new outpost. This is going to be the new International Space Station. We're going to be talking about working there from the mid 2020s, probably for the rest of the time, probably.
Exactly. And then it also serves as a jumping spot for deeper space missions like to Mars. So I'm really hopeful and very excited for this mission.
Awesome. Well, thank you so much, Rachel. Thank you for everyone out there on YouTube that was watching. We will be back next Thursday. As we said before, our theme is going to be our place in the universe. We're going to be talking about scale, distance, basically kind of like creating a roadmap of our universe and where we are in it. And if you would like to donate to us, we would very much appreciate. You can go onto our website, spacecenter.ca, and go to the Donate Now button. Rachel, good to see you again. Hopefully we'll be hanging out in person soon. But for now, see you later.